Welcome to Chibuzor Mathphysics. In today's video, we shall be dealing with equations reducible to exact. So let's have that down. Okay. So for the equations m dx and n dy, we can say that it is equal to 0. Then we have 1 over m, the partial derivative del n by del x minus del n by del y is a function of y, that is to say f of y, and the integrating factor of this will be the exponent of the integral f of y dy. So let's have that down. Yeah, so that's what we are saying for the equation m dx plus n dy is equals to 0. Then we can test the exact using 1 by m into the partial derivative del n divided by del x into minus del m del y, and this is a function of y only. It is a function of y only, that is, we are talking about this function f of y, and we are going to use this if as the integrating factor. It will be the exponent of the integral of f of y dy. So let's take a question and try to see whether they are exact, and if they are not, we go ahead to solve the exact differential equations. So let's have our solution. The equation is solve 3x squared y power 4 plus 2xy dx plus 2x cubed y cubed minus x squared dy is equals to 0. So let's have our solution. Given differential equation, the given differential equation is this equation. So let's write that down. So this is the given differential equation, and we can call this our equation 1 because this equation is in the form of mdx plus ndy. So we are going to have mdx and ndy. Let's get some space and then have that down. So since the equation is in the form of mdx plus ndy, we simply have m, it is 3x squared y power 4 plus 2xy, this, and this is our n. So now we are going to partially differentiate, so partially differentiating with respect to y and x. Let's have that down as well. So if we partially differentiate, let's have the del m del y. This will be we partially differentiate this with respect to y. This will be 4 by this. This will give us 12x squared y cubed because we differentiated this plus 2x plus 2x. Of course, the derivative of y here will simply be 0 because it's that. So this is what we have. We also partially differentiate del n into del x. In respect to x, here we will get 6x squared y cubed minus 2x if we differentiate that. So this is what we have, and from this equation we see that del m by del x is not equal to this, so it implies that therefore we can say that this equation 1 is reducible to exact differential equation. So before we go into exact differential equation, let's also test this using homogeneous to know if it will work using homogeneous factor. So let's do that. Homogeneous, we know that f1 is xy into y dx plus f2 will be given by xy x dy, and all this must be equal to 0. In this question, our x1 is 3x squared y squared plus 2x. So let's have that down. If we have our f1 and f2 to be equal to 0, we are simply evaluating mx minus ny. This will be 3x cubed y power 4. If we take this here, y power 4, just multiply this by y plus 2x squared y, 2x squared y minus 2x cubed y power 4 plus x squared y. So this is what we have, and it will give us, if we subtract this with this, we will simply have x, because 3 minus 2 we simply be left with x cubed y power 4 plus 3x squared y, and this is not equal to 0. So equation 1, therefore this therefore means that it is non-exact. So we can say that equation number 1 is reducible to exact. So let us go ahead to reduce this equation to exact. Go ahead using this formula to reduce this to exact. This will give us 1 divided by del n by del x. Del x is simply 3x squared y cubed y power 4, this y power 4 plus 2y. So let's have that 1 into 3x squared y power 4 plus 2xy. If you refer to the original equation, then that's why this is square, but this is not. Refer to the previous equation, and this will be multiplied by the whole of this. Let's go ahead and do that. That will be 1 by 3x squared y power 4 plus 2xy into 6x squared y cubed minus 2x minus 12x squared y cubed minus 2x, that is del n into by del x minus del m by del y. So that's what we have here. Let's get rid of this. So when we subtract these two, this is what we have. Because we have 6 minus 12, you simply have minus 6x squared y cubed minus 4x, because we have 2, so minus 2 here by this. Get minus 2, you have minus 4x divided by, we can try to factor out, we have x and y. So we have x, y, so that we have only 3x y cubed plus 2, and this will also give us this will be 2. Let's factor out 2x, because we have x here into 3. Now observe what happened. This is exactly the same thing, so we can cancel this with this and cancel x with x, so that we are left with negative 2 over y. What happened here now? This exactly is a function of y, and we can now apply the integrating factor of y to integrate this and see. So if we simply integrate this function of y into this, we will simply have exponent of the integral negative 2 over y, negative 2 over y, which will give us, if we bring negative 2 outside, we will simply integrate dy by this, which will give us the exponent of negative 2 log y, which will be equal to, this can be equal to exponent of let's get rid of this, equal to exponent of log y as log y minus 2, which can be written as y into 2, which is the same as 1 over y squared. So now we need to multiply if, the integrating factor, to equation 1. If we do that, we simply get, if we multiply both of them, this is what we get, and we can say this is y power 4, so we can cancel this, so that we have y power 2 remaining. Cancel this, here we have 1 remaining. Did the same this side, we simply have this. 1 will remain. We also do the same here. So this implies that what we are going to do, so we are left with this. We can call this now equation 2. Let's call this equation 2. Let's take this to be m1, and let's take this to be n1, so that now we can use this to evaluate our integrating factor. Let's now partially differentiate dm by dy. dm, let's differentiate this in respect to y. We'll get 6x squared y minus 2x divided by y squared in respect to y. Let's differentiate this in respect to x. This will be d partial derivative. This one is 1 in respect to x. This will give us so now we have arrived at this point. We can see that del m by del y is equal to del n by del x. Therefore, we can say that equation 2 is exact. So if it is exact, let's go ahead to use term mdx and integrate this function and find the required solution. Equations, we are going to integrate mdx plus terms of n not containing x dy is equals to c. So let's it will be the integral of 3x squared y squared plus 2x by y. If you look at terms of n not containing x, there is none, so it is simply 0. As we do our integral, this will go with this.